let's roll back a bit. And I was reading the next proof, which is for these overlapping events. And I was really like, come on, dude. You sure? I remember on my old slides had a really, really complicated proof. And it went down to a really trivial proof. And I'm like, no, it can't be that easy. So I expanded it a little bit. And as I did it, expanded it a little bit, I realized that I kind of knew this before, but I was ignoring it, about when do we turn things around. Remember in order to make the code look more aesthetic, we had the bird talk about the last edge, right? So that the subinstance was from the beginning. And in our first example, that wasn't a problem because the graph was symmetric. But quickly, our graphs are no longer, oops, let's not do that. Yeah, so here, you might remember, we had, these are the friends that we had, right? If I was sitting here with, and so I'm comparing the ith guy with the jth guy. I'm working on the ith j entry, longest common subsequence. Are people with me here? Right? And then I see that my characters are different, right? Then I follow the edge down to this subproblem, right? And similarly, if the bird tells me to go past the G, the Y value, then I move over there, right? So that's our graph, and right. Otherwise we match them if they're the same, right? If they're the same, we match them and we move past both of them, right? Everybody kind of good here? So and if we were doing a reduction, then we produce that graph and we give that graph to the oracle and we're done, right? But if we decide that we want to code the thing up, right? Then we want to turn stuff around. And so that was our turning around. And so here, we're going to have a new, we're going to turn the graph around, right? We're going to just take an entire graph and turn it around. So what does that mean? That means from a bird friend algorithm, I'm personally working on, Pooh Bear here, he's working on a subinstance, right? And the subinstance is, I consider the first I letters of X and the first J letters of Y, and right, I'm going to find the longest common subsequence. So I look at the last characters, right, of my strings, and if they're different, then I know that one of them can't be in my solution, right? So I ask the bird which one can't be in this solution, and if she tells me drop the last of X, right, then I move up, right? And now what do I give my friend, right? Because then I recurse on my friend, and my friend has this smaller subinstance, right, where we subtracted one from I, right? And similarly, we can go in this direction, right, where we subtract one from J, or similarly, we can go subtract one from both. They're the same, so we take them and go both, right? So you can see it's the same except going in the other direction. And so when you look at the code, actually this code was, let's jump over to the next one. You can study that if you want, but here I'm saying, I'm personally trying to solve the problem where I have the first I of X and the first j of y, and then I look at my last characters, and if they're the same, then I know that my bird answer is k equals 3. K equals 3 is just the name of the case, right? And then what I do is I ask my friend for the subproblem, the cost of the subproblem when I is one less and j is one less, right? And then my solution is one bigger, right? Does that make sense? People kind of following that, right? And on the other hand, if these x, the last characters are not the same, then I have two bird answers, right? And if she answers, in the one case, I subtract off one from I, and I have the same solution. And the other, I subtract off one from J, and I have the same solution. And then I take the best of those two, right? Does that make sense? All right. So that was just looking at the code again. Here we, here's the filling in. This is just a picture of how I think about what order to fill them in. I think for that kind of this entry right here, who are my friends, right? And my friends are those three, right? So I have to fill it in some order in which those are filled in before that is. And as we said, pretty much any order works. I mean, any reasonable order, right? And the base case is this guy here. This is when there are, we're considering 0 of the Y letters, right? And if there's 0 of the Y letters, then those would be my friends, but there's nobody over there. And I kind of know the answer that if one of your strings is empty, then your longest common subsequence is empty, right? So that fills, that's our base case, right? And so here's the code that fills it in. And then here, as this is a different example, but it's the same idea. Here we have the bird's advice, right? Is here, right? This 0 and this 0 are matching. So the bird's advice is to go this way, right? And while in this case, they're not matching, and the bird says to delete the one of that, right? And you can follow that path back, right? Everybody kind of follow that? All right, we did knapsack, and you have to turn its graph around too, but it's pretty straightforward. And then here's the code, which is pretty straightforward. It says, right? I asked the bird whether to take the. Here, what is my problem? My problem is I have a knapsack of size V prime, right? And I want to pack it with the first I objects. So I ask her, should I put the ith object in or not, right? And if she says exclude it, right? Then I delete the last object, right? And my solution is the same, right? Just let's say whatever my friend did, I give the same because I'm not putting that last object in, right? You know, and if on the other hand, if she says put it in there, I have to check to make sure it fits, right? So here I'm checking, is the volume of my knapsack big enough to put it in? And if it's not, then I say, hey, bird, you were wrong, right? And I punish wrong answers, right? And if otherwise, then what's my solution is I make the I put it in, right? I put the ith object in, and that makes the volume of the knapsack smaller by VI. It makes one less object to consider, right? And my friend fills in that solution, right? And then what's my solution is the same as my friend's solution with the I added back in, right? Are you guys really following this? Because usually, sort of, you got any questions about it? Oh, right. This line here is commented out. That was because the solution's really big, right? So to copy it from this entry to the array to this entry of the array takes order in time, and we're lazy. So, and we don't really need it. What we really need is the cost and the birds to go forward and do this. All you need is the cost. But I'm also saving the birds of advice as we went along, so that then you can go backwards and find the solution. Right? Remember that? People get the bird friend game, okay? Oh, yeah. Well, suppose the bird tells you to put object I into the knapsack, and your knapsack is the size V prime, and it doesn't fit. Right? Here, this says I can't subtract off V prime because it just doesn't fit. Right? And then at that point, I have to know, at some point you have to know, don't put an object in a knapsack if it doesn't fit. All right, so, okay, good. So here, down here, where we find the cost when that's consistent with the yes answer, and the best cost consistent with the no answer, and then we take the best of the best, right? So down here, we're saying let K max is going to either be the 0 or the 1 answer, and it's the one that maximizes the cost, right? And if this happened, then minus infinity won't be the maximum, and we'll be sure not to put the object in, right? Does that make sense? I mean, we could have. That line is basically like, oh, the bird is wrong. We're not going to take this and make it as long as possible. Yeah. I mean, we could have, you could imagine putting the code in some other complicated way where it says, in this case, make sure 2 is not your answer. But I felt this was the easiest way of doing it. Well. Or like what it would continue. Yeah, it says this isn't a good option, don't go for it. Right? Yeah. No, it's just this current one's too big. Right? We filled up the net. It might have been good earlier on, right? But we've been filling up, we put lots in the knapsack, and now the next object won't fit, right? And so, right, well, yeah, we don't trust our bird, right? I mean, because we are trying all possible bird answers. I mean, the truth is we don't have a bird option. I mean, I guess we just did the longest common subsequence example, and there I had a big if, which said, if the last 2 characters are equal, then this has to be the solution, right? Otherwise, there are 2 possible bird answers, right? And we could have done the same. We could have put at the top here, if the ith object doesn't fit in the knapsack, then you have to say no, right? Otherwise, you try putting it in and you try not putting it in, right? That would have been equivalent code and maybe equally good. And I did this 20 years ago and I did it this way, right? So partly my goal, even remember with the longest common subsequence, I had an earlier code where it looked more like this. And one of the reasons is I really try to make every program look the same, right? Every program means what do? We loop over sub-instances, then we loop over bird answers. Well, here it's not a loop because there's only 2, so we do one and do the other. So we do the one answer, and then we do the two answer, and then we take the best of the best, right? I mean, one advantage of this is it's really we're just trying to make all the codes look the same. And why do we do that? Just to make it easier for you to get the pattern, right? And easier for the TA to mark them, and right? Everybody good?